Hello, everyone. It's great to see so many of you connecting to a webinar today, the second webinar in a row. The first one we had on the dashboard. And today we're going to speaking about OpenWeather and, of course, our lovely APIs and what are the best and most effective practices of utilizing them. The host today will be myself, Daniel Mintz, and I'm part of the business development department. And the main speaker will be my colleague Vanya, a recruiter from our technical team. The session will consist of two parts. The first one will be basically Vanya's guide into the world of APIs with explanation what APIs are, what are the various possible APIs that are developing under the OpenWeather roof, and of course, showing you a live demo of basically how to make an API call and everything around it. And later on, we'll have a Q&A section to make sure that we can answer all of the questions that you could have. Just briefly, before we dive deeply into the technicalities and specifications of our APIs, let me just quickly mention that OpenWeather is one of the leading global providers of meteorological data and analytics, working with more than 7 million clients across all sorts of industries, energy, healthcare, logistics, you can name it, will be there. And on the other hand, we have a big foundational arm under which we provide thousands and millions of pounds worth of data completely for free for students, developers, research and development organizations, universities, and basically any other entities who require kind of data for their researchers and projects. So our data is already an integral part of numerous of applications and developments worldwide. And we're making this webinar to make sure that we can help you to become one step closer to creating your first own layer of weather intelligence. Well, I believe enough of the words and we can start some action. Vanya, over to you. Thank you.
Yeah, thank you so much, Daniel, for that amazing introduction. Let me just quickly share my screen. Okay, great. Can everyone see my screen? Okay,
Yes.
great. Awesome. Yep, so yeah, as Daniel mentioned, I will be walking you through how to make API calls, what exactly is an API, what are the kind of APIs OpenWeather provides, and a little bit of the basics as to how to get started with using them. And we'll also be going through a live demo so that you guys can get started with understanding on how to make your first API call, and the opportunities are endless from there. So what exactly is an API? So an API essentially stands for Application Programming Interface. And while that may sound a bit technical, the core idea is actually pretty simple. So think of the API as, say, like a waiter in a restaurant. So you, the customer, would look at the menu and place your order. And then the waiter would take that order to the chef who prepares your food. And then the waiter brings it back to your table. So you yourself would not go into the kitchen, and you yourself would not tell the chef what exactly to cook. The waiter handles all of that. So similarly, think of the API as a messenger that allows two different software systems to talk to each other. It defines a set of rules that sort of lets users send requests and get back responses. So if you take a look at the diagram, you can kind of see that at the top you see a user sitting at a computer, maybe on a weather app in their browser, say they're on OpenWeather, and when the user wants to check the temperature or the live weather in their city, at the back, the app essentially sends a request to the API with the parameters of that request being the city, the temperature, and then the API will fetch that back from the server, so it acts as sort of a middleman. So you yourself are not directly accessing the database or the backend. The API fetches the information for you on your behalf in a sort of controlled and structured manner. And so whenever you use sort of a tool to check the weather, track a package, book your rides, there's a high chance that an API is working behind the scenes to make that possible. So now that you understand a little bit about what an API is, why exactly are these helpful? So first and foremost, APIs simplify integration. You don't need to reinvent the wheel every time you want weather data, or you're making a payment, or even logging into a system. Someone's already built that system to access either data or a service, and APIs let you connect to it with a few lines of code. Secondly, they speed up development. So essentially, instead of building the entire weather engine from scratch, you can simply call, say, the OpenWeather API and get the data instantly. And this means, you're making things a bit faster and you're less worried about reinventing the wheel or sort of building something entirely again. And third, and one of the more important factors, is that APIs enhance security. So they act as a controlled gateway between you and the external service. You don't essentially directly access, the storage unit of where the data is stored or where the server's sitting. The APIs act as a sort of filter and enforces sort of rules and permissions, enabling that you as a user have certain limitations in access as designed by, say, your tier or your user level in a system. And finally, APIs help support scalability. So if you're the one who's building an API, and as your app grows and more and more users come in, or you're adding more and more features, APIs let you sort of break up the system into manageable parts. And this modularity is really the key to building applications that stay fast and reliable over time. So in short, APIs are how modern apps stay connected, efficient, and secure. Then now let's take a little bit of a look as to what kind of APIs OpenWeather offers. So at the core of the platform is the OneCall API, and this is essentially an all-in-one service. So it gives you the current, historical, short-term, and long-term forecasted weather data. And it also gives you severe weather alerts, the weather overview with the human-readable summary, and it sort of makes it the ideal integration for a wide range of use cases. It gives you we also provide the current weather, hourly and daily forecasts, and all through a single endpoint. So secondly, you also have the current and forecast weather data APIs. And this is what we're going to be exploring later on in our live demo today. So these are a bit more focused, and you can call them individually for just, say, the current conditions at a certain location, or a 5-day forecast or 16-day forecast, depending on what your application needs. And these are great if you're sort of starting out to explore APIs, building something lightweight, and sort of beginning a sort of small project. And next, something especially relevant for industries like energy and agriculture, we also provide the solar irradiance and energy prediction services. So this API estimates sort of the solar panel output based on the weather and cloud data. And so if you're building tools for energy management or smart grids or sustainability dashboards, this is a really powerful feature to have. And finally, OpenWeather not only offers forecasts and current data, but also historical weather data, which allows you to access past weather records for a given location, which is incredibly useful for trend analysis, insurance risk modeling, or even training your own small models that can have climate data as a feature. And of course, beyond these, there are tons of APIs, more APIs available, such as air pollution monitoring, agro-specific data sets, and so on and so forth. And I would highly encourage you to take a look at what all OpenWeather offers at the end of this webinar. So whether you're building something simple like a daily weather app or something complex like an energy optimization platform, OpenWeather has a toolkit that sort of scales with your needs. So now let's get a bit started as to how you kind of can start making your API calls. There are a few key features you might need to keep in mind before you directly jump into the code. And one of the most important things is understanding what an API key is. So when you sign up on the OpenWeather website, you'll be able to generate a key from your dashboard, just like what you see on the screenshot here. So this key is essentially your unique identifier. It tells OpenWeather who you are every time you make an API call, or essentially when you make a request. So why do we need these sort of API keys? And the main reasons are, firstly, authentication. so that the API or the messenger knows that you have permission to access the service. And secondly, it also helps manage how often you can make requests depending on your plan, which comes under access control and rate limiting, which we will take a bit of a look at in the live demo as well. And thirdly, you can also monitor how your app is using the API. Essentially, how many calls have you made? What kind of calls have you made? And you can kind of get an idea of tracking and usage analytics. On a really important note, it's really, really important to remember to never share your API key publicly, especially when you're uploading code to GitHub or asking questions in public forums. If someone else ends up getting their hands on your API key, it could exhaust your API quotas or even lead to an additional charges on your account. So once you've got your key, make sure that you don't share it. And once you've got it, you'll be able to make your first real API call. And so before we jump into actually calling the API, it helps to understand the kind of operations we're performing when we use APIs. So now I understand the title seems a bit very technical. So API operations are just essentially what kind of calls an API is making, which are listed on the screen below, and I'll go into them one by one. And the REST architecture essentially stands for representational state transfer, but don't worry, you don't need to memorize that. What you really need to know from that is that there's a sort of standard sort of system or sort of structure for how APIs are built. And these APIs essentially expose something called as endpoints. And all of this comes under a sort of set of rules, which is called as REST architecture. So don't worry too much about that. The more important thing that you need to know is that these endpoints or API endpoints have certain operations. And these listed on the screen are the most commonly used operations. So the first one is a GET operation, which is used to retrieve data. So think of it like asking the API, hey, what's the weather like in London right now? You're not changing anything, you're just reading the data. And so second, you also have something called a POST request, which is used when you want to create something new or submit a new resource. For example, when you're submitting a form or an application. And then you also have the put as well as the patch sort of operations, which are both used to update data, whereas patch is typically used for partial updates and put is used for a full update. And delete, as the name suggests, removes data. So essentially for OpenWeather and most weather APIs or data APIs, you'll primarily be using GET operations or GET requests because we're generally tending to sort of retrieve data or retrieve something from a service. So if you remember just one thing from this slide, it's just that GET is your go-to method when calling APIs in general, and that's what we'll use when we walk through our first sort of demo API call. So what exactly does a GET request or a GET operation look like? So on the screen, you can kind of see an example of a GET operation or a GET request to one of OpenWeather's APIs. So let's sort of break down what's happening over here. So you can see you first have your sort of base URL, which is api.openweathermap.org, followed by /data/2.5/weather, which is sort of telling it which specific API we're calling. And then you have a question mark and a Q is equal to followed by a bunch of parameters. So in order for you to call this API service, you might need to pass in some additional information. For example, when you're making an order in a restaurant, you're not going to tell the waiter just, get me some food. You're going to tell him specifically, I want this starter, I want this drink. So those are what you call query parameters in an API. So when you're making a call for this API service, which essentially gets the current weather, you're also going to tell it which location to fetch the weather from. And of course, most importantly, you're also going to send it your API key, which will authenticate, saying that, yes, this is this current user, this user has sort of access to this API. And so the API will know that, yeah, it can fetch the data back and pass it to you safely. So that's a bit about the GET request. So once you send this request, what does the API actually fetch back? You typically get API responses in something called as a JSON format, which is a sort of standardized format for kind of structuring sort of your data. It doesn't necessarily have to be a JSON format. Typically, you'll have several other formatting options, but the one you use primarily when you're coding is the JSON format. So you can see a little snippet on the screen as to how it could look, and you can kind of see that it has the coordinates, you have the weather, you have sort of sub-parameters in the weather with the description, what's the main weather, and so on. So this is just a small snippet. In our live demo, we'll be looking at a longer response and a bigger example, so you'll be able to understand a bit better what's going on there. So now that you understand what an API is, you've kind of understand how to make a call, you understand that you have to do something called use an API key. What are the best practices for actually making API calls or making a series of API calls, which is typically what you will be doing when you're making applications or even sort of creating models. So first, we have to understand that APIs aren't unlimited. For example, OpenWeather's free tier allows for up to 60 requests per minute. And if you go beyond that and you're not on a paid plan, you will start getting blocked or you'll receive error codes. So if you're building something that sort of fetches data frequently, you should either add a short delay or you could upgrade to a higher tier, which would allow you for more requests depending on your application. And so the reason for this is, so imagine, say, you're in a crowded restaurant. If you're not made a reservation, you're going to have to wait. Making a reservation kind of sort of is synonymous to you being in a higher tier, so you're going to get immediate access. But if you've not made a reservation, you're going to have to wait, which would kind of limit how often you can make requests or how often you can receive data. So just to keep that sort of analogy in mind when you're trying to understand why APIs aren't always unlimited. And so you also have something called a response code when you make a request. So you will also not only receive the data you requested, you will also receive an additional response code, which will give you an indication as to whether the API request works successfully or not. So if you see a code that begins with the number 2, typically like 200, that means it's a successful request and you've got the data that you were expecting. Usually if you have a 400 error or 4 followed by a certain number of digits, it typically means something went wrong on your end, which means maybe your API key was missing, or maybe your city name was misspelled, or something went wrong in processing that request. And 500 errors sort of indicate that the issue is not on your end, but it's on sort of the server side or the other side of the API, which in most cases, if you retry after a short period, it should work. But if not, it's a rare case, but if not, you should contact the API that you've been using. So these codes are really helpful for debugging and sort of keeping, making sure that your API calls are working as intended, especially as it grows. So as a beginner, if something breaks, your first move should always be to check the response code, which will usually give you an indication as to what's happened. And finally, before we get into the live demo, there is something called a documentation. Now, OpenWeather itself, as you saw, offers a ton of APIs. How do you know how exactly to use each of those APIs? How do you know what sort of the query parameters each one is expecting? How do you know what kind of response you're expecting to get at the end? So in all of those cases, your most go-to tool is going to be the documentation. And the good news is it's very, very beginner friendly. It's very, very, simple and intuitive to understand. You can, I will leave a link in the chat shortly, so you can take a look at the documentation of OpenWeather's APIs and get a sense of how it's going to look. So typically, you will see these sections in a documentation, in API documentations. And those include sort of the endpoint URL, which was sort of the base link, which we saw earlier in the slide. And you will also have the parameters. So what query parameters do you sort of expect to pass in? You will also sort of have a sample call. Typically, you will get an example, a real example, which you can copy just to test if your thing is working, if the format is right. And you will also have the sort of expected response format, which is what kind of data you're expecting to come back and how it's structured. And finally, you may or may not find this in documentations, but typically you will, is the rate limits, which is essentially, depending on which tier, how many calls can you make to the specific API within a certain time range. So now that you have a good idea of, what you're doing, what an API is, how to sort of handle multiple API requests, what to do if you've gotten wrong, let us deep dive into the live demo. So I will pop a link in the chat, which all of you can go to. So the tool which we're going to be using today just to demonstrate is something called as Google Colab, which is typically used more for their GPUs, which people use these to train models, but it's also a good resource just to share and learn the basic code. And so if you go onto the link I've clicked, you will see something called as a notebook or Jupyter Notebook, which already has some code into it. I will share my screen so you can have a look. Yeah, so you should be seeing something like this. And if you want to sort of run this code alongside me, you will have to sign into your Google account. But yeah, if not, you can just watch along and set it up later as well. So first things first, we're going to be using Python, the programming language, to make our first API call today. And you can make an API call in typically any language. I've just picked Python because it's a bit more easier to understand the code for beginners. And you can always expand this to any other sort of programming language which you're more comfortable in. So initially in Python and in most other programming languages, you will have to sort of import something called as libraries, which are sort of helper functions, which will tell the code sort of what to do. And the first one, and the most important one for today, is something called as the request library, which is what's going to sort of help facilitate your actual API call. We also are going to be using the JSON library in order to structure that format and sort of view it in a proper form. And for the purpose of today, we will be using one of Google Colab's sort of inbuilt libraries, simply because I'm going to show you a safe way to store your API key so that you don't have it sticking here in the code. So one way you could sort of run your code is to just sort of define a variable called API key and paste your API key there. But that is fine if you're not going to share this code somewhere, or if you're only using it for just practicing and you're not going to put this on GitHub or in public forums, then it's fine. But I would encourage you to, best practice is not to stick the API key directly in the code. Google Colab has an option to add in a secret variable. So if you click on this over here, the secrets button, you can actually add in sort of keys with their name values. So yours will likely be blank. I will be sharing a key in the chat. So for the purposes of this webinar only, so those keys will be deactivated post this webinar. And if you want to, explore the code a bit more on your own, I would encourage you to go ahead and make your own API key and start exploring, at least in the free tier. So I will paste this key in the chat. Great. So now what you can do is, so I will just delete this for the purposes of the demo. You can click on add a new secret, name the API key whatever you want, and sort of paste in that value over there. And if you want to also sort of hide it from people's view, you can click on this icon. But so you are sort of, even if someone else opens this notebook accidentally, they won't see it. And in order to share this key with the code, you're going to have to give this notebook access. So once you've set this up and you've run this bit of code, it should execute and not give you an error. And so whatever value was over here is now stored in this variable API key. So great, now that you have your API key set up, let's get into actually making your first API call. So we are going to be calling one of OpenWeather's current weather APIs, which is the one I showed in the slide earlier. So you can see that this is the base URL of the API, which tells it which API to call. And these are the query parameters. So if you look at it, you basically need a latitude, a longitude, and of course your API key as a basic way to make this call. So now I've set up the latitude and longitude for Bangalore, which is where I'm currently based, but feel free to change these parameters where you currently are at so you can access the weather for where you are. And so once you stored them in variables, you can place them in the format as I've shown here. So you can modify this based on which API you're calling, and usually this will be sort of presented in the documentation, so it shouldn't be too hard to set up and find. And so now that you've got your base URL, you've got your query parameters set up, now it's actually making the API request. So as I mentioned earlier, we're going to use the requests library. And as I also mentioned in the type of operation, we're making a get request or a get operation because we are sort of retrieving data from OpenWeather's APIs. And we're going to pass in this URL that we've defined over here. And this, once you've run that, it will return the response and it will be stored in this response variable over here. So just running this bit of code would actually just give us our first API, would be our first API call, and we would get our response. But as mentioned earlier, some of the best practices to do is to check for your additional response code before you actually try to access that data. So over here, I'm checking if there is a successful request. So if I get the response code of 200, that means it was successful, and I can access the data from that response. However, if it doesn't return a successful response code, it is good to print out what the actual response code was. Typically, APIs also come with response text, which is essentially an error message, which will give you a bit more idea as to what actually went wrong. So if you just run this cell, you will get the response from OpenWeather's API. Now, because this format is a bit hard to look at, you can just run this bit of code to see it in a bit of a structured manner. And so let's take a look as to what we've got here. So now we have the coordinates, which were what we originally gave in as input or the query. We also have the weather. So what is the main weather condition? And the description. We also have the temperature, the feels like temperature, the min max, the pressure, humidity, and so on. So now you'll notice that the temperature units are in Kelvin. So if you, again, I would highly recommend going to the documentation, which I actually think I will paste in the chat so you can have a look simultaneously. So if you look through the documentation, you will see that by default, the units of these parameters are going to be in standard, but there is a way where you can send in an additional query parameter and set them to either metric or imperial based on what you require. And so, yeah, so you can see that there's a lot of data just coming in from this sort of one API request. And you can obviously, change this to a different API later on and just explore what other ones OpenWeather offers and get a bit of an idea as to how different APIs give you different responses. So yeah, that's step one. You've made your first API call, which will be great. We're super proud. It's really cool. And before we sort of wrap up this session, I also want to go through a few cases where you might get errors or things may go a bit wrong. So what happens if you don't pass in the right input parameters? So let's say I define something that doesn't make sense for a latitude value. Obviously, latitude should be an integer or essentially a float value. It can't be sort of a word. That doesn't make sense. So if I run this, I get a error message. So it doesn't give me status code 200. It gives me a status code of 400. And it says, and the message it gives is wrong latitude. So usually it's best practice to, when you make an API call, to add in this check for the status code and also print out what the error message could be, because it really does tell you, and it's really helpful for sort of debugging to see where your code went wrong. So as in this case, you can see that, yeah, it says that latitude doesn't make sense. It doesn't, that's the wrong latitude. So the code won't work. So another thing is what happens if you say don't pass in an API key. So if you can set just the API key to an empty string, everything else is the same. And if you run that, you get another error message. So you get this time a 401, and the message it says is there's an invalid API key, and please see this URL for a bit more information as to what went wrong. So as I mentioned in the slide earlier, anything that starts with a 4 is typically something went wrong on your end while making the request. Maybe like earlier the input parameters were wrong, the query parameters were wrong, or some of them were missing. In this case, the API key was missing, which is why it didn't run. So it's really good practice to sort of set up this as not directly just making the request and getting the data, but to check for the error for the status code before you try to access the data from that API. And the last topic we'll touch upon is something called as rate limiting. Um, so as mentioned earlier, you can make a certain number of requests in a given time frame, typically for APIs, and this will be mentioned on your sort of tier of or level at which you are. Usually free tiers are about 60 calls per second, and if you want to upgrade to a higher tier, obviously you can go to one of the pricing pages of OpenWeather or whatever API you're using and upgrade as necessary. So how do you actually trigger sometimes rate limiting? So on your API key, the one I've provided right now is on a higher tier. So you will not get this message when you run this code. But typically, if I say run a API call request 100 times in a row, like back to back successively, these calls do not take over a second to run. They take less than a second to run. So if I run 100 in, say, less than a minute, obviously I will hit that limit of the free tier, which would be 60 calls per second. So in this case, eventually I would start getting an error message that looks like this. So it's code 429, which is again starting with 4, so it's an error on our end. And the message is that the count has been temporarily blocked due to exceeding the request limitation of your subscription type. And then you can go to select a higher subscription if you want to, or typically you might have to wait for your account or your keys to be unblocked, which will also be written of your sort of your account. So yeah, so typically adding in, how do you actually combat this if, say, you want to make a successive sequence of requests, but you don't necessarily want it to be within a certain time. So in that case, one way to do it, or the most common way to do it, is to add a delay. So this bit of code essentially makes an API call and then waits for a second and then makes the next call. So even if you're running it over 100 times, it will not exceed your sort of quota within that time frame because you will not be making more than 60 calls in a minute. So yeah, that is essentially brings us to the end of the demo. I will quickly go back to the slides.
Okay, Vanya, thank you very much. It was indeed very interesting and great to listen. You know, as we said, it's always the picture worth 1,000 words. So all of the demo tips, I hope that in general it became more clear and easier for you to understand what are APIs and how to work with them. So amazing session. Thank you very much. And I believe currently we are closely coming to the Q&A section. And I am ready to kickstart with actually very, very important question for today. And the question is how to get an API key. Well, here I would like to actually share my screen, Vanya, if you allow me to do so. Okay, perfect. I think you can see me now. And basically, if you come to our website, openweathermap.org, directly on our pricing page, you will find several options which will basically allow you to start coding and to start developing already today. The first one is our flagship product, One Call API 3.0, which allows you to have up to 1,000 API calls per day completely free of costs. It consists of various historical, nowcasts, forecasting options, incorporates weather alerts and other weather parameters, and can be an absolutely great kickstart of your weather intelligence project. So please go directly to our website, app, and subscribe here. Secondly, while we scroll through our lovely pre-offer of various subscriptions and product capabilities, of course, our lovely dashboard, please one more time explore our previous webinar about its capabilities and meteorological service. We are closely coming to a section stating free access. Well, as I already mentioned before, we put a special appreciation towards developing a research and development community. And specifically for this purpose, under the OpenWeather Foundation realm, we have created a student initiative, which basically is described on our doc site. And under this initiative, you receive access to the developer and medium plan, which basically provides, again, both current historical and forecasting data options. So if you are a student, professor, researcher, or you would like data for some interesting projects that you are currently developing, please get access directly on the website. Or if you find something here that you would like, for example, to add any additions or any other plans, please text us directly, and we are always happy to have a discussion with you and see how we can help your projects with our data and resources. And lastly, we have a free weather data subscription, which is available absolutely to everyone. So no matter who you are, developer, professional, student, child, I don't know, doesn't matter. Please, if you want, you can come to the website and start exploring our data already today. Well, I hope that this have provided you a nice overview of where you can start receiving your first API key and start gathering data today. And we can come to the next question. Vanya, if you would like to take a part here, over to you.
Yeah. Yeah. Yeah, I can see in the chat someone's asked how long our API keys work. So API keys typically, as soon as they're created, they work for as long as you have your account. You can add or remove API keys in your dashboard, but typically they are indefinite unless you exceed quotas, and in which case they'll be temporarily blocked. But otherwise, yeah, they are there indefinitely. Another question I also saw was what kind of advanced alerts for things like predicted rainfall levels that might lead to flooding, crop damage, etc. So if you take a look at some of the APIs that OpenWeather offers, you can see that rainfall alerts, weather alerts is one of the API solutions we do offer, which you can obviously integrate into whatever project you think you're doing. I will see if I can find the link and leave that for you to look at later on. But yeah, you do have sort of alerting as an API option, which you can take a look at and integrate. So you can sort of add a setting for when to trigger, oh, if the rainfall level is above this level, it does something. If it's below, it does something else. Okay, so another question that I saw was, what are the sort of supported response formats? So if you again look at sort of the documentation that I provided earlier, link, you can see that in the response, you will kind of have a list of response formats. I can just share my screen quickly just to show you. Yeah, so over here, you have obviously the JSON, which we discussed at the beginning. You also have XML, which are the most commonly used ones. Some others might have a few other response formats depending on what kind of API it is and what kind of service it is. Typically for data ones, you have JSON and XML. Okay. Another question that we have is there any limitation on programming languages to use? Usually, no. Most programming languages support making API calls regardless of what kind of programming language you're using, because it's sort of how you interact with different tools across the webs. Um, so that is there's typically usually most programming languages that you would come across or you would use you would be able to make API calls in that. Another question that was there was is how is it secure? So yes, as sort of we touched upon earlier, it is made secure by using facilitating API keys, which enables limited access depending on what kind of person is using it, what kind of tier or sort of subscription level you're at, and so that sort of adds as a secure system between the two. Okay, I can also see a few more questions popping up in the chat. Can we embed maps to external applications like web apps? Yes, you can embed maps into external applications. Usually, there's sort of different ways to do this depending on the type of map and how interactive you want it to be. But yeah, usually you would either say use maybe the Google Maps API, or you also have a few other options, OpenStreetMap, and you can sort of access their API docs to get a bit of an understanding as to how to go about doing that. Are there any limitations to supported geolocations? So it really does depend on the API. I do think that OpenWeather Map covers pretty much the entire Earth. And if there is any location you try to do and come across that it doesn't work, you should definitely reach out to us so we can see what went wrong. But yeah, typically there's, most of our APIs don't have limitations. And how far out, another question is how far out can alerts happen? So that there is a possibility of some threshold amount of rain in XX days. Yeah, so that also depends on sort of which API you're using and which sort of subscription plan you're on. So I do think that you can set sort of weather alerts for up to a certain days depending on your subscription. You can also access the forecast a certain number of days out depending on what plan you're on. I think the free plan allows you for up to 5 days in advance, and if you want something a bit more long term, you can definitely explore some of the other API options we have in sort of paid tiers. And of course, if you're a student and this is for a project, you should definitely reach out to us on our student initiative so we can see how we can help on that front.
Vanya, can I actually add
Yeah,
on to the question?
yeah.
Because I believe there could be another layer here about this like customization of the thresholds and various climatic parameters. This is a very good question, as this is kind of exactly what we're trying to do with our enterprise level clients and like more sophisticated projects where we're trying to establish various interdependencies between weather and its applications in our daily life. So 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 what I'm trying to mean here is that basically every single weather parameter has its different impact and its different approach to various industries and various applications. So, for example, if you say that you need to explore various risk modeling things, like you want to understand what is the specific thresholds while directly in your location with this amount of precipitation, flooding will happen. Or, for example, you would like to model retail analytics and you would like to understand what is the correlation between, for example, sunshine and beer starting to selling better. And these are exactly the threshold that we're trying to identify and create this, customized approach to every single area, industry, or even product set where we're tailoring weather and our personal approach and response to weather, to what's actually happening on the ground, to make sure that this alerting can not only be in the format like flooding is happening, make sure you can avoid the area, but more like insights and to provide you insights and preparedness for what's happened next from both risk averse perspective and the optimization perspective. Yeah, that's it from my side. Thank you. Great question.
Yeah, yeah, if there are any more questions.
I can see one more question here about what types of projects that can be developed using weather APIs. Well, great question, and I can answer it. Well, this is where the business development part lies. So, to be completely honest here, the only limitation is your imagination. Because what we can see, what our users can do just from basic weather apps to creating advanced roof misting systems for better cooling in the areas where, for example, energy is not as provided as in the other parts of the world, to creating, again, retail analytics analysis, to creating long-term town infrastructure using weather data, especially considering, current environments of the heat waves, flooding, storms. This is very important from analyzing renewable energy potential and optimizing it to, I don't know, identifying long-term health trends in accordance to weather. The applications are so many, and the amount of areas where weather data can be useful is very hard to limit. There is a saying which we truly believe, that weather is a third to time and place, and very often we do actually see this happening in reality. And a lot of times what we believe the problem with weather data in its usage, it's not that you cannot build a lot of projects around it, or it cannot be useful in a great amount of areas. It's mostly our understanding of how weather can impact our everyday lives. Because again, when you say that once 16 degrees threshold is hit, everyone would like to drink more beer. Yeah, that sounds like reasonable. But when you actually try to implement it on the, for example, operational business cycle, there are a lot of areas, and there's a lot of little niche hints where by utilizing a layer of weather data, we can create a higher level of insight and general efficiency. So I'll come back to the first thing that I have said. The only limit is your imagination and the amount of things that you can gather working with weather data, and weather intelligence is plenty. And again, we hope that our resources and this webinar will help you to become one step closer to actually, making this a reality. Great question. Thank you very much. Well, what else is interesting here? I think we have covered practically everything. Vanya, do you see anything else?
Yeah, I don't think that.
Oh yeah, I can see one. Juan is
Oh,
asking, what is the degree of precision of the measurement at a given point comparing to an atmospheric station? That's an interesting question.
that's
I think I'll give it over to you here.
yeah, no, that is a really good question. So that typically also will be mentioned in the API description, since it varies depending on which API you're calling. For example, pollution APIs will have a different degree of precision compared to some of our weather APIs, but you will most likely be able to look at this information in the API descriptions. So if you go to sort of the documentation link that I provided earlier, um, and click on it, you in the description you will likely be able to see sort of what the precision is within each parameter. But yeah, that's a really good question.
Yeah, and to quickly add, if you require any sort of like specific accuracy reports to be done, this is absolutely possible. Just say us the location, say us your need, and we will compile all of the accuracy reports and information for you directly for your scope. And at the same time, I will actually just quickly post a link to the chat, which describes the accuracy of our model and basically our technological stance. So you could explore and see what's in there. Yep, thank you for the question. Great question. All right. I think we are coming to an end of our second webinar in a row. I hope that you have enjoyed it. I hope that we have managed to answer your questions successfully and provided you the general understanding and foundation of how to work with the APIs. Vanya, thank you very much for your efforts. It was great to listen. Thank you very much for your demo. And thank you everyone who participated, who have listened to us. Please, please, please let us know if you have any questions after the webinar, or if you have any projects where you would like to discuss any sort of the support or further assistance. I'm always here and we're always here for you. So, well, I wish you a great continuation of your day, more sunny days, less precipitation days. And yeah, enjoy everyone. Have a good one. Bye bye.
Thank you, everyone. Bye bye.